Hello everybody and welcome back to Advanced Maths. Today we're looking at kinematics integration. So, here we have an astronaut and the astronaut is starting at 0 meters away from its beginning, of course, and it's going to move 5 meters. It's now 5 meters away. Now, it will move backwards 2 meters. How far has the astronaut traveled? Well, some people would say he has moved 3 meters. Other people will say he's moved 7 meters. This is the difference between displacement and total distance traveled. The displacement of the astronaut now is 3 meters from where he started. The total distance traveled is 7 meters. He traveled 5 meters one way and 2 meters backwards. So therefore, there's a difference between displacement and total distance traveled. And this is important when we're handling speed, distance and time, or displacement and velocity. Let's see this on a graph. So here we've got a velocity time graph, and we're going to talk about the different parts of this graph. Firstly, we're interested in when this particle is at rest. The particle is at rest when it crosses the t-axis, when the velocity is equal to 0. It's at 0 at these 2 points, that's when it's at rest. Rest means velocity is at 0. Now we've also got these points here. Whenever the velocity is positive, it means the particle has a positive velocity and it's moving to the right, or sometimes we say it's moving up. Here, where it's green, the particle has a positive velocity. And when the particle is below the axis, this is when it's negative. This is when the velocity is negative, or it might be moving to the left, or it might be moving down. It's moving in the opposite direction. Now, when we've got a velocity time graph, the area under the curve, this blue area, gives us the displacement, as is how far it's travelled. So this blue area here will give you the displacement. And there's 2 ways to think about this. Firstly, to work out the displacement of the particle at any time, you differentiate the velocity, you integrate the velocity between the start time and the end time. That is how far it's moved. That's a very simple integral, and normally your calculator can do this for you. That is displacement, and it's the integral of velocity with respect to time between A and B, where A and B are the start and end times. Normally, A would just be 0. Now, if you were to work out the total distance travelled, that will be imagining that the velocity is always positive. So here, with this graph, we've made the velocity always positive. And to do that, we've used the absolute value symbols. That is the 2 lines on each side of the velocity. And the absolute value basically just makes it always positive. And so now we can integrate between A and B of the absolute value of velocity dt. That's the difference between displacement and total distance travelled. It's a really important distinction, and I'd like to make note of both those equations. Let's see this in an exam-style question now. So a particle is moving at velocity t squared minus 5t plus 6. For 0 is less than or equal to t is less than or equal to 5. Calculate when the particle is at rest. So the word rest means the velocity is 0. So we're going to make the equation for velocity equal to 0. And this is a quadratic, so we'll solve it really easily by factorising. We get t minus 2 times t minus 3, and that means that t is equal to 2 or t is equal to 3. We solved it by factorising, and therefore the particle is at rest at 2 seconds and 3 seconds. On a graph it looks like this, and we know it's a quadratic because it's a t squared graph, so it will have a U shape and it will look something like this. That's part A, we know when it's at rest. Part B, calculate displacement after 5 seconds. So the displacement is really easy. We just integrate the velocity between the start time and the finish time. So we'll integrate between 0 and 5, that's the start time and the end time. And the velocity is t squared minus 5t plus 6. We'll integrate this by using our power rule, and we'll get this. If you don't know what I just did to get that, you need to revise integration before we continue. That is integration, and you need to be perfect at it before we continue this video. I will link my integration video below. We substitute in t is 5 and t is 0, like this, and we get this. And when this is equal to 0, the second bracket just completely disappears because everything is 0 there. That disappears, and we're left with this. And when we work this out, which is quite long and quite boring, we get 55 over 6, which is 9.17 meters. Sometimes you want to get a calculator for that. However, if you was in a non-calculator exam, you would have to substitute the 5 in and work it out on paper. Dealing with the fractions, it wouldn't be fun, but you can do it. So the displacement of 5 seconds is 9.17 meters. Finally, let's calculate the total distance travelled after 5 seconds. So here, I'll show you the long way, and then we'll realise it's a bit too long, so we'll do it on the calculator. So we're going to work out the total distance travelled, and to do this, we're going to integrate the velocity, making the velocity always positive. And the way I can do this is I can do this as 3 separate integrals. I can integrate between 0 and 2, and then between 2 and 3, and between 3 and 5. The middle integral, the between 2 and 3, we know that is a negative velocity. So to make it positive, we'll just subtract everything in that integral, and that'll make it a double negative, which will make that positive. I'll just say that again. That middle integral between 2 and 3 is negative. You can see it on the graph where it's red. To make that positive, I've just put a minus sign in front of it, so it's a minus minus, and it'll become positive. I can now integrate all of this, and I integrate the velocity like this. However, this is massive. This is too much effort for this video, and I don't think you'll be asked like this in the exam. I think that'll be too complicated. So let's use a calculator, and let's integrate the absolute value of velocity between 0 and 5 seconds. On the calculator, it looks like this. So we're going to go maths, and then we're going to go to the integral symbol here, and we're going to type in our velocity. The abs button, ABS, will give you the absolute value. Look at the buttons I'm pressing. I'm typing in my function now, and I'm going to between 0 and 5. And I press EXE, and I get the answer is 9.5 meters, which is the total distance travelled. Just notice the difference between displacement and total distance travelled here. Displacement is slightly less at 9.17, and that's because we moved backwards at one point, which means our displacement went backwards a little bit. That's how you work out total distance travelled and displacement on the calculator. Now, this is another question. It says a particle moves in a straight line. The velocity of the particle at time t is given by v of t is t sine t minus 3, between 0 and 10 seconds. Find the times when the particle is at rest. So we'll use the calculator here to see where it has x-intercepts. We'll go to the graph and we'll type in our function. I've already done that for you here to save time. Press EXE and we get this graph here. I'm going to change the window if I need to, but at the moment it's between 0 and 10, which is I want it to be. Now I can press G-solve and root, and that gives me the roots of the equation. That's where it crosses the x-axis. So the two values of time that work there are t is 6.74 and t equals 9.08. We've rounded that to 3 significant figures for the answer. If you missed the calculated steps there, feel free to rewind at any point of this video. I know there's a lot of buttons that you have to take in. Find the total distance travelled by the particle. Okay, so here we're going to integrate the equation for the absolute value, and I've shown you this picture on screen. So I'm not going to type it all in again, I'm just showing you what you need to type in, and you can follow the steps that I did before to get 37.096 or 37.1 meters. That's all you have to do, and you get the right answer. Finally, we get asked to find the acceleration of the particle at t equals 3 seconds. To find the acceleration from velocity, we're not going to integrate, we're going to differentiate. So we'll differentiate our equation and figure out the acceleration at t equals 3. You can differentiate this on pen and paper, but your calculator actually does this really nicely for you. Let's go to the calculator, press maths, and d over dx. We'll type in the equation, x sine of x minus 3, and the x value where we want to evaluate that is 3. We want to evaluate it at x equals 3. And we get minus 2.82 meters per second. And so the acceleration at 3 seconds is that. That's everything from today's video. Thank you for watching. Remember to like and subscribe to support the channel. We also really appreciate if you share this video with your friends who are also on your course so they can benefit from some Addvance fun. Check out advancemaths.com for lots more IB revision. And thank you for watching. Good luck in your exams.